Let's draw the Bohr diagram for aluminum. Aluminum is number 13 in the periodic table. That is an atomic number. Now what that means is it has 13 protons in the nucleus, and that's what makes aluminum aluminum. Boron, above it, has only 5 protons in the nucleus, so that's what makes boron boron. Carbon has 6 protons in the nucleus, and that's what makes carbon carbon. Now, you have to recall that the mass of a proton is 1, the mass of a neutron is 1. So, if the mass of an electron is very, very tiny compared to the mass of a proton or neutron, we don't have to worry about the mass of electrons. In fact, it's less than 1/1000th the mass of a proton or a neutron. So we'll just ignore the masses of the electrons. So given that the total mass is 26.98, we subtract off the 13 taken up by the aluminum, and we get 13.98, which is very close to 14. So we round to it, after you do the subtraction, round to the nearest whole number. So you draw a circle in the middle to represent the nucleus, and we write 13p for 13 protons and 14n for 14 neutrons. Next, we need to fill up the shells, or orbits, with electrons. Now, if there are 13 protons, there has to be 13 electrons, because 13 positives and 13 negatives make for a neutral atom. So we start filling up the shells. The first shell can have up to 2 electrons. So because it's filled, we're going to pair them. The next one can have up to 8. So what I do is put them in the north, south, east, west directions. And so I still need more because I need 13 total. So the second time around, I'm going to pair them up. And as to why they're paired up, you'll learn about that in grade 10. Okay, so now we have 2 and 8, that makes 10. We need 13, so that means we need 3 more. So we fill the last shell with unpaired electrons. And there is our Bohr diagram for aluminum.